I'm architect Rishabh, and I have been working in the BIM profession for more than 4.5 years. And I have worked on different type of projects like residential, commercial, airport, metro, and infrastructure projects in different countries like India, USA, UK, Middle East. And basically, our as an architect, our main focus is to design and build the sheets and everything which can be provided to the site as well as to the industry for the construction of the PEB. So, what we'll be talking today is why fast track matters, why PEB works, why roofing must be focused on, and why teams must align early. So, why fast track construction matters? Majorly today, uh, what the client, what everyone wants is that the construction should be done in a faster way, but the quality should be there. So that's why it is important. Also the cost control as well, like the delays and reworks should be avoided, and less confusion on the sites, like less revisions is very important. So this is why the change is happening. More work must happen in parallel. Better planning is needed before the site even starts. The construction must support speed, not slow it down. So, fast track construction is not only about saving the days, it's about making the whole delivery path easier to manage by making it aligned and strategic. So, PEB is not a compromise, it's a smart choice. Uh, it's a simple comparison. Like traditional route was more construction was done on the site only. More handoffs between the teams were made on the site only, like the architecture, civil, the MEP, and all. Changes are harder to absorb. Like, for example, if there is any clash coming or anything, so we have to do the rework or some change had to be made on the site only. Time risk is usually very high. And in the PEB route, more work done before the site because it's majorly done in the industry only. It's constructed in the industry in a very controlled manner. Fabrication brings better control. Larger spans for the warehouses, for example, are very easier to plan in these cases, and execution becomes more predictable. So, how PB accelerates delivery? Majorly, design logic is fixed first. For example, whatever the design is, it is fixed. Then it is the components and standardized fabrication are done off the site in the industry by the machine. So the precision is very high for that. Site works become more clear and more sequenced. Construction happens faster with fewer unknowns because majorly the works are done by the machines only. So the precision is very high for that, and commission starts sooner. That means the construction on the site is done faster for that. So the key advantage is not only speed of the construction, it's the reduction of uncertainty before the building reaches the site. So whatever the uncertainties were before in the traditional method won't be in the PEB method. So the precision starts before the site does. What that means, majorly when we are since I'm working in the BIM industry, so what we have to do, we have to first design and we have to make the 3D model like a digital twin in the software only, like Revit or ArchiCAD. So there, what we do, we design the different structures, we cross check it, we see the clashes which would be there if it is done as per what is planned right now, as per the sheets or whatever it is done. Then we align the teams, the architecture structure, we coordinate between them, we plan better by fabricating through the sites, and eventually when the site work starts or whenever the construction for the PEB in the industry starts, the model which is there, the drawings which are there are very precise for that, and there is very less chance for any confusion, so and any rework on the site. So the better information is also flown because the precision is high, the clashes are resolved, and it is done very methodically. So when BIM is used well, fast tech delivery becomes more controlled, not more chaotic. What this mean? That whatever the design or whatever the model we are making, it is more controlled. We have all the information which is there. We can see it in 3D, 2D, everywhere, sections and elevations, everything. And that way we can plan better. We can even do the detailings for that, whatever the construction or whatever the equipments are needed for that. So large span design is a performance decision. What this means, that for the large spans in the traditional method, what happens, we start the site from one corner and then we end to the another corner. But that takes a lot of time. So for that, we have to there are a lot of labor which is required there, a lot of people which is required there to supervise them, a lot of things are there, a lot of time would be there. But when we do it through these things, through PEB, through BIM, so there is less internal blockage, like fewer columns. We can plan better for that. Better workflow is this, like we can plan better how the machines, the storage, the vehicles and everything would be planned, how they'll be moving around more freely. We can do the future flexibility, like we can give the timelines to the client, like how it will be there, how much time it would take. We can even check from the industry as well, from the factories as well, how much time they'll take, how much time in which they can deliver to us. So that way the construction is comparatively easier. And since the construction is majorly done in the industries only, it is a safer option for safer, and the circulation can improve. How? Because it decreases the problems which would be occurring on the site, because major of the construction is already being done through industries. They just have to fix it on the site. So that is why large span are not only a structural topic, they shape daily use of the building, because in large spans there is a lot of load would be there, dead load, live load, wind load, n number of loads are there. So through we have to plan it in a way that it should be very easier to manage, easier to walk through, to circulate between. So where this approach creates the most value, majorly for the warehouses, like fast movement, storage efficiency, and easy expansion. For manufacturing, like open floor plates, support machines, and material workflow. Hangars and support spaces, like for the airport hangars and support areas, for that, large clear areas are often essential. Sports and utility buildings, where the wide span is required to improve the functions and crowd circulation. Logistic parks, quick delivery matters when the operation must start soon, because in these industries, the time is very essential to start, how fast we can start, how fast they can start their offices, they can start their working. And then commercial support buildings, like back of house spaces, often needs these high flexibility. So the stronger the operation need, the stronger case of the coordinated PEB approach is required for that. Now, next topic is roofing. So, roofing is not just a top layer of the building; it is a very essential part of the building, because it affects comfort, the cost, and performance. So majorly roofing controls the thermal comfort, like the temperature which would be there, because majorly the sunlight when it falls on the roof, it depends a lot how what the roofing the material is there, how much energy the building requires to cool down to maintain a particular temperature. The weather, is there a good weather protection is there, maintenance load, like whatever whatever the maintain load is there, the dead load and everything is maintained, and building life. So, if the roofing is treated only as a covering, the project can pay paid for later through heat gains, leaks, poor comfort, and higher the upkeep. So, what good roofing should deliver? Mainly, these six are the very important things. Firstly, is the insulation, like how much heat it can reflect and keep the building under building temperature under control. Weather resistance like rains, winds, even the snow in some areas. So, and exposure. So, how it handles these: durability, reduces early wear and tear replacement, like the even small changes in the temperature or the climate, the roofing should endure that. The daily daylight strategy can support balanced natural light. Low maintenance. It should be it should avoid any repair and upkeep. So it should be made in a way that it should go on for the majority of the time without doing much maintenance for that. And lastly is the solar readiness. It should support future energy plans, like for example if there's any planning for the solar panels or something. So whatever the plan could be, so it should allow it the load and everything to support that. So good roofing choices may look simple, but they have a strong effect on how the building feels and performs every day. In hot climates, roofing becomes a business decision. For example, poor roofing can lead to higher heat gains, more load on the cooling, like there is required for the ACs and everything, faster wear in the harsh weathers, like the roofing requires continuous maintenance, more maintenance over the time. When the roofing is made better, we can see the difference, like lower the heat transfer in the building, so comfort is there, the temperature is maintained, there's less pressure on the mechanical systems like the ventilation systems, the air control systems, and stronger long term values.
Rishabh, we can take a break and probably resume. It's
No, no,
okay.
it's fine, it's fine. So in architecture, why architecture matters: performance is stronger when design quality stays in the room. For example, architecture is very important when we are doing all these stuff like planning and everything. So the building should the building should still feel intentional and well composed. The materials are very important as per the climate and everything. The proportions should be there. The identity, like every building should carry a unique identity when we are designing those in the architecture. So the clients do not only want a building that works, they also want a building that looks considered and feel right for its purpose. So speed should never force design quality over the conversation. So what that matters, that the quality should be there, whatever the speed of the project, whatever the design, whatever the construction we use. Next is integrated design is the real advantage. So why integrated design? So the building works best when these pieces meet early. Like first the architecture intent, then they are coordinated with the structure and span, then through services and routing like the MEP and everything. Then the roof is planned accordingly and eventually the site is executed. So when these decisions are linked early, the building systems becomes easier to build, easier to manage, and stronger in use. Risk reduction across the project lifecycle. So a fast project still needs confidence at the every stage. So the concept for when we are designing any building, the concept is very essential to make the building unique. Then it should be coordinated when the design is completed. It should be coordinated well. Then the fabrication phase. So in when we are giving the designs to the industries, it should be well fabricated. Then the installation should be done very methodically, and it should be very precise as well. And lastly, the operations. So operations mean support, comforts, durability, the maintenance which is going on even after the building is made. The future ready buildings are coordinated buildings. What that means, speed, performance, and long term use need to move together. So the time is very important. The performance of the building, the comfort, durability, everything is very important in that building. Thus, it should be sustainable. The materials, energy usage, it should be maintained well in that, and the adaptability. Like for example, the large spans often make later changes easier. So the future of construction is not only about building fast, it's about making the speed work with intelligence, quality, and design. So why how the architect still has a very key role for that. So this shift needs judgment, not only technical speed. So the architect helps keep the full picture in view. For example, the function and movement of the building, the proportion and user experience, how the building would, the proportion would be, how the experience would be. The architect should coordinate between the teams like structure, map, the site team, everywhere, so that way they can maintain whatever it is being built on the site, and even the industrial process as well. That is why this change is not only about speed, it is about making the building decisions earlier, before gaps appear between design intent and execution. So this is where architecture, BIM, and delivery thinking comes together. So in other words, speed works best when someone is protecting the quality of the building. So what are the takeaways from this summary? This simple talk. So PEB works best when treated as a strategy, not a shortcut. So when it is being strategized good, it is not a shortcut. It helps the building and even the clients as well and everyone to start the working, start everything in a quick way. Large span planning improves function as much as the structure. Roofing choices directly affect comfort, energy use, and the upkeep, which means the maintenance. BIM helps reduce uncertainty before the site pressure begins. The strongest project align design, structure, services, and execution early. So when all these things are done, the project it is done in a precise way, and it is a faster way to build that. So yeah, thank you all, and thank you B2B magazine to give me this opportunity to talk.